This video is about the homologous series of organic compounds that we have to study for chemistry GCSE. An homologous series are a group of compounds or a family of compounds which have the same functional group and react in the same way. Now, first family that we have to look at are the alkanes. Now, I'm going to use the alkanes as an example, and we'll look at the structure of them in a moment. So this is some data about alkanes. Now, as you can see, we've got methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. Now, one of the things that we notice is that there is a regular increase in the molar mass. As you can see, it goes up from 16 to 30 to 44, 58, 72. So it's a regular increase of 14. The melting point, as you can see, increases all the time. Similarly, the boiling point, and because the melting and boiling point change, so does the state of matter. So they're going from gases to liquids, and the heavier ones will actually become solids. Now, the densities, and then we start with just pentane here, only starting with the liquids. So as you can see, there's a regular increase in the density. They are all insoluble in water, and none of them conduct electricity. So we can one of the things about homologous series is that there is this regular increase in the physical properties of it because the molecules get bigger. So because the molecules get bigger, the melting and the boiling points become higher because the intermolecular forces are greater because there's a larger surface area. Now, if we look at other properties, now if we burn alkanes, all of them will form carbon dioxide and water when they're burnt with sufficient oxygen. Now here, what we've got is the enthalpy of combustion, and I've got them for alkanes, which are the blue line, and the alcohols, which are the red line. So the obvious thing you can see, first of all, is that these are straight line graphs. And the reason why, so there's a regular increase from one to the other. They're parallel to each other. And the reason why they're parallel to each other is that they both increase the same amount each time because we add one carbon and two hydrogen atoms. Now, the first member of the alkanes, we've got methane, which we draw as C bond H bond H bond H bond H, CH4. Then we've got ethane, which we draw as C bond C, H, and H in each of the positions there. C2H6. Next one up then is propane. 3 carbons in this chain. And as we can see, we've got, move back there slightly, 1, 2, 3. These are said to be saturated because each of the carbon-carbon bonds are single bonds. And last but not least is butane. Now I'm going to need to take butane away to draw it. So here we've got 4 carbons in a chain. Each carbon forms 4 covalent bonds. like so. Now, the formula of this group. So if we look at them, this is C4H10. Let's look at the others now. Ethane is C2H6. And propane is C3H8. And methane is CH4. So this means that the general formula of this group is Cn, where n is the number of carbon atoms, H2n plus 2. So the next member of this series will be pentane, which will be 5 carbons. 2n will be 10, plus 2 would be 12. And we said, the most important thing to remember here, these are saturated hydrocarbons and they're generally fairly unreactive. Now, the next family are called the alkenes. Notice the difference. And this ene makes it completely different. So, let's look at the structures. The number one thing about the alkenes is that they have a double bond. So, if that's the case, it is impossible to have methane because you've only got one carbon there. So, the way we draw ethane will be like this. Double bond between there, and on the double bond we split out the hydrogens. Next member then will be propene. Here's propene. Three carbons and our double bond. Our double bond is here. So our structural formula for this is put your 3 carbons first of all. We've got a double bond here, so put the double bond on, single bond there. And remember again that each carbon must form 4 bonds. So you've got 3 hydrogens on the end. There's only 1 on this middle carbon. And we've got 2 at the end there, like so. Here's butane. Again, we've got the double bond there. And the functional group for the alkenes is the double bond. So the formula for butane, let me just move it to the side a bit. So put our 4 carbons, 1, 2, 3, 4. We've got the double bond at the end here. So starting at the far end, we've got 3 hydrogens. So it's got our 4 bonds here. This carbon's got 2 already, so there's only going to be 2 hydrogens bonded. So we can see there and there. This carbon, it's only got 1 hydrogen, and these 2 are splayed out at the end. Now, looking at this, these are said to be unsaturated because they have got a double bond, and each carbon doesn't form 4 single bonds. So we've got C2H4 for ethene, we've got C3H6 for propane, and for butane we've got C4H8. Now, so that makes the general formula Cn, when is the number of carbon atoms, H2n. Now, the functional group here, the double bond, makes the alkenes relatively reactive. And all their reactions, they want that double bond to break and something to add on, so it becomes saturated. Now, our next family are the alcohols. This family has the basic straight chain, followed by then an oxygen joined to a hydrogen, and this is the ol bit. So here are our alcohols. This is methanol, which has 1 carbon atom, as we'd expect with meth. So we've got meth. we've got hydrogen, 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 then O bond H. And it's this bit, the O bond H, which is the functional group. Next up, ethanol. And here's our ethanol. Obviously, again, 2 carbon atoms. We've got 3 hydrogens on this N carbon. 2 here. And then the O bond H, the functional group. Now, lastly then, we've now got propanol, obviously, which you've got the hang of now already, and you can see that we've got 3 carbons. Now I'm going to take this away so it's easier to draw. So 3 carbons. Each carbon again's got to have 4 bonds, and that's the golden rule in all our chemistry. And then the O bond H on the end. And to save a bit of time, I'm just going to draw butanol because it does the same. 4 carbons in the chain. Again, hydrogen, 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 and O bond H. Now, how we write the formula for these? So, methanol, we go CH3, and we leave the OH as separate because it is the functional group. Ethanol, as you can see this time, is going to be C2H5OH. And propanol is going to be C3H7OH. And lastly, butanol, that's going to be C4H9OH. So this time, the general formula for the group will be CnH2n plus 1 OH. So this is this homologous series. Now, one of the big things is that the OH makes this a much more reactive group. Now, the next family are called the carboxylic acids, and these have completely different properties from what we've seen before. So, first member is methanoic acid. Now, the way we do this is like this. We've got 1 carbon attached to that then. It's a hydrogen. We have a double bond with the oxygen there. And we've got an O bond H here. Next one is ethanoic acid. Now, obviously, again, as you can see, we've got this Q, which is the important thing about carboxylic acids. So if I take it away, we've got carbon with 3 hydrogens on, which is at the start there. And then we've got our functional group for carboxylic acid, which is this Q bit, like so. Now, propanoic acid, again, so we need to realise it'll be 3 carbon atoms. We've got our Q at the end, the functional group. So this will be like this. Put our 3 carbons. Got our 3 hydrogens here. 2 hydrogens on this one. And then our Q. Now, obviously, for butanoic acid, it's going to be 4 carbons. Put our hydrogens on. and our Q group here, there. Now, in this family, the reactivity of the carboxylic acids is down to this hydrogen here. This is what makes them acids, and these will ionize in water just like ordinary acids, sulfuric, hydrochloric, and nitric. Now the last group we have are the amino acids, and these as a family are different from the others. Here's one of the simplest amino acids. Now, first thing you notice that it's got the Q on the end, so this is your acid group. But the other thing, at this end here, the blue atom is a nitrogen, and this is an amino group at the end, NH2, and this is a base. So having an acid end and a base end means these readily join together to make polypeptides by joining together. And those will then build up to form proteins. And it's because of the fact that it's got these two functional groups, the acid functional group and the base functional group. This is what makes them very special molecules. Very unusual to have two functional groups. This is the one that we need to know the name of. Now, as you will realise, it is the functional group which determines the chemistry of the molecule. And by changing the functional group, you change the reactions. So here we've got an amino acid. Here we've got a carboxylic acid. And here we've got an alkene. The number of carbon atoms, all that really affects within a homologous series the physical properties. It is the functional group that has the overriding importance.